All right, so 25 says the number of history books in a store if there are 4 more than 3 times the number of math books. All right, so we're looking for how many history books, but they relate it back to math books. So math books is where you actually want your variable. So math books is whatever. All right, they said X. When we do this, it says 4 more than 3 times. You could have actually said 4 plus 3 times the number of math books, or like they did it, 3 times plus 4. But if I were to take the math books, multiply by 3, and add 4, I would get how many history books I had. That's what they were looking for. Evaluate means plug in and complete the operations, whatever they are. So you will have to do order of operations here, which is why I said if you struggle with that on the first chapter, you want to make sure you completely understand it, because we're about to take it one level up and do plugging in and evaluating, right? So the first thing you're going to do is substitute the values that they have given you for the specific variables. And then you are going to do order of operations to come up with your final answer. So look at example 1 here. Example 1. All right, example 1 says 3a squared minus b plus c cubed. Then they have said a is 1, b is 4, c is 3. They want us to evaluate. So when we do this, we're going to rewrite what they gave us, and we're going to fill in the variables with the substitution of what they told us they are. So we're going to say 3, and instead of a squared, we're going to write 1 squared. Minus b. So instead of b, we're going to write 4. And plus c cubed. Instead of c, we're going to write 3. You don't necessarily have to write the parentheses, but a couple things that happen. First of all, if you were to plug in a negative number, it matters whether or not it's in parentheses. So anytime you're plugging in, technically you're putting it in parentheses. So had that been like a -1, it would have mattered whether or not I put the negative on the outside or the inside, right? And so I always use parentheses just to remind myself that I'm doing that exponent first. The other thing, the reason I would maybe put it right here is what happens if I did not put parentheses there? It's like 31 squared. Would that change my answer? Oh, ever so slightly, right? And so you do want to pay attention that you're not confusing yourself by how you write something. And so I usually put parentheses there just to keep the clarity. All right, so my order of operations says to do exponents first. I'm going to do the exponents. By the way, 1 squared is what? So 1 squared is 1. So I have 3 times 1 minus my 4 plus 3 cubed. What is 3 cubed? 27. Multiplication, 3 times 1, right? And then I'm going to do addition, subtraction from left to right, all right? So 3 minus 4 is -1. -1 plus 27 is 26. Plug it in, do order of x squared, y, z squared. And they were kind and gave us fractions. -1/2 is x, y is -2, and z is 1/4. All right? Again, we're going to take this and plug in what they've given us. Instead of x, we're going to write -1/2 squared. Instead of y, we're going to say -2. And instead of z, we're going to say 1/4 and square that. All right? How do I square a fraction? All right? So if I do -1/2 times -1/2, I'm going to get what? Positive 1/4, right? So I'm going to get 1/4. So I just did -1/2 times -1/2. A negative times a negative gave me a positive. Multiply across. 1 times 1 is 1. 2 times 2 is 4. Okay? So I got 1/4 there. My -2 is here. What about when I square 1/4? 1/4 times 1/4, which gives me what? 1/16. Now, when you're multiplying, you can look at it this way. That -2 is over what denominator? It's over a 1. So I have 1/4 times -2 over 1 times 1/16. When I multiply fractions, what can I do here? Yeah, I can cross cancel. So I can cancel some things here. I can cancel this 2 and this 4 if I want to, right? And then once I've cross-canceled as much as possible, I just multiply across. 1 times -1 times +1. What's my numerator? It's -1. 2 times 1 times 16 is 32. And that is my answer. I cannot reduce it. So we move into formulas. You will see formulas a lot in science, all right? Science loves formulas. Geometry, next year we used to have geometry. Geometry loves formulas, okay? A formula is just an equation that expresses relationships between related quantities, and they use those related quantities as they put variables there. Because equations help us solving, but then also it helps us to create this function that's going to work for everything. The example they give us here is converting Celsius to Fahrenheit, which Celsius means nothing to me. I know in science they love Celsius, but when my thermometer at home switches to Celsius, I'm like, this is useless. Like, I need you to be in Fahrenheit because I don't know if there's a temperature, just off the top of my head. Mostly because you multiply by a fraction and then add 32. So, so when you have Celsius, you multiply by 9/5, which is the same thing, by the way, as multiplying by 9 dividing by 5, and then you add 32. Obviously, freezing is easy to do. There's also one, what is it, -40, I think, that is the same for both, but that's beside the point. So 9/5 Celsius plus 32, and the other conversion is, the whole thing times 5 ninths minus 32. But if you have Celsius, you can figure out what your Fahrenheit is. You plug it in. You are evaluating. You're basing it off of this formula that you have, and then every time you have a Celsius, you can plug it in, multiply by 9/5, add 32 every single time and convert it. All right, so some formulas use some of these symbols throughout from now until you stop having me as your math teacher. You'll see these things, but going over them, some of you are familiar with, some of them you may not be. Hopefully we're all familiar with this guy right here. Equals, we know what that means. This is pretty intuitive. An equal with a slash through it means not equal to. This little guy right here I use when I round, okay? So let's say I have a repeating decimal, 1.33333. We round that typically to 1.3. Technically it doesn't equal 1.3. Technically is it approximately 1.3. And you will see this little wavy equal sign. That indicates they have in some way rounded. Okay, they've in some way rounded that. It is approximate. We did talk about subsets and elements. On that same note, anytime you see a slash through a symbol, it just means not. So not element. Hopefully you've seen these last four. Greater than, less than, greater than or equal to, less than or equal to. If you don't remember it, it is always from left to right. So the tiny end is pointing to the smaller guy. That means the one on the left is bigger than the one on the right. The one on the left is smaller than the one on the right. These two combine your greater than, less than, and your equal sign. If you were to smash them together, you would get your greater than or equal to, less than or equal to. And it just means it can equal that number or be smaller, equal or be greater. All right? Some symbols you will see, and hopefully have seen most of these. These are some common formulas that you will see and will be expected to know, and you probably have used them. Perimeter and area. All right, next year especially we'll do areas of circles. We won't do it as much in here because I'm not going to make you approximate pi at 3.14. Next year you'll get to use a calculator and use the actual pi that your calculator rounds it to, which is a little bit more significant. But perimeter just means distance around. So when you have a rectangle, you're going to add your two widths and your two lengths. So the formula for the rectangle looks like 2L plus 2W. That is the distance around. Area, however, is if you were to shade it all in. That is length times width. Length times width. Your square. Well, your square, all of your side lengths are the same. If all of your side lengths are the same, you could add them up. S plus S plus S plus S. A much easier way to write that is just to take one of the side lengths and multiply by 4. That is distance around. It is technically the same formula for a square and a rectangle because a square is a type of rectangle. But your side lengths are the same, so that's why it is side squared. It is just side times side or length times width. These two are technically the same. It's just that your length and width are the same measure for a square. Circle. We're not going to do circle as much. You will see it a ton next year. 2 pi r. This is the distance around the circle. If you were to take the string and go around the circle and lay it out, you would say 2 pi r. The area is pi r squared. Square your radius. Multiply by that pi. Triangle. Triangle has 3 different side lengths potentially. Sometimes the side lengths are the same. It just depends on the type of triangle. But anytime you're adding your distance around, you're literally just adding each side. Triangle has 3 sides. Add them up. You will get the distance around the triangle. The area of a triangle is if you were to take a rectangle and cut it in corner to corner. That's why it's 1/2. All right, so you take the base times the height, but then you cut it in half. If you think of a square piece of paper, and I wanted a triangle corner to corner, right? That would make my triangle. That's why it's 1/2 base times height. All right, it's the same as the rectangle, but it's half of a rectangle. All right, these are some formulas you need to know because you're going to start seeing word problems using these. Now, I want to talk to you about keywords. How do I know if I'm talking about perimeter, or how do I know if I'm talking about area? Anything that goes around the outside. So like one of the ones they love to use is fencing. They're fencing in a garden. Well, if you fence in a garden, you're going to put that around the outside. That's going to be perimeter, right? Now, if you were to take a wall and you were to do the trim around the wall, that is perimeter. But if you were to paint the wall, that is area. That's covering the entire inside, okay? And so you'll see some terms that make you think, what are we doing with it? And you have to use your logic skills. Am I going around the outside? That's going to be the perimeter. Am I filling it in? That's going to be the area. And eventually, when you get to geometry, you'll get volume, which is a 3-dimensional, right? All right. So using formulas, first and foremost, use the right one. If you use the wrong formula and plug your numbers in correctly, you started in the wrong place, right? So use the right formula, substitute the values they've given you, and then evaluate. That just means use order of operations and solve. So let's look. This one, they were nice. They actually used the word perimeter. Find the perimeter of a rectangle whose length is 8 centimeters and whose width is 3 centimeters. I do want to point out that they have used units here. All right, units. The reason I want to point this out is these units must be the same before you plug it into a calculator or into a formula, okay? Because if you plug it into the formula and your units are different, you are comparing apples to oranges pretty much, okay? And so I say this because standardized tests love to say like this is in feet and this is in inches, right? And then all of a sudden you go to calculate it and you've compared feet to inches, and that's not a good comparison. It needs to be inches to inches or feet to feet, okay? Which we're not going to do any unit conversions right now, but we will eventually. And you'll definitely do unit conversions in science, all right? So perimeter, we have to decide what formula I'm going to use. The perimeter of a rectangle. The perimeter of a rectangle is 2 times the length plus 2 times the width. So first I'm going to determine what my formula is. This is my formula. Then they have given me my L and they have given me my width. Now that I know those variables, I'm going to substitute it in. So I'm going to say 2 times, and instead of L, I will write 8, plus 2 times, and instead of width, I will write 3. Now I'm going to do order of operations. What do I do first? Yeah, the multiplication, 2 times 8. Multiplication, 2 times 3. And then I am going to do my addition here, 22. And what were my units here? Centimeters. All right, so for right now, if I ask for a circle, you're not going to have to evaluate it with pi. I want you to leave pi in your answer, all right? So they want the area of a circle. So area of a circle is pi r squared, all right? They said the radius is 9 feet. So they have given me my r. Pi is not a variable. Pi is a constant. It is 3.14157, whatever, this long, non-terminating, non-repeating decimal. It's a comparison between the diameter and the circumference. It is a constant. So you do not plug anything in for pi. It's not a variable, all right? But I am going to plug something in for this r. So the area is going to be pi. And if I plug in my 9, I'm going to square it. What do I do here? The exponent. What is 9 squared? 81. So if I leave it in terms of pi, I'm going to put my coefficient first, even though pi is not a variable. You still want to put it in front. So my area here is going to be 81 pi. When I do area, I have moved to 2 dimensions. All right? So I technically multiplied 9 feet times 9 feet. All right? Which means I have feet to the 2nd power. So perimeter is always going to be 1 dimension. area is going to be 2 dimensions. When you go to a second dimension, your units are squared. All right? So you'll notice on perimeter, I left it centimeters. For area, I did feet squared. And if you did volume, by the way, it would be cubed. You would have added a 3rd dimension, okay? So perimeter is 1-dimensional. Area is 2-dimensional. All right? So your unit's actually square there. You did feet times feet. Think about if I multiplied x times x, I would have x squared. All right? And that's the same thing with your units.